Welcome back to our channel. In this session, we're exploring the essential principles of microservices architecture, highlighting their key features, benefits, and the challenges they address in modern application development. In the previous session, we discussed the key differences between monolithic and microservices architectures. If you missed it, I encourage you to watch Session 3 for a better understanding. Now, let's dive into our current topic. Microservices is an architectural style that structures an application as a collection of small, loosely coupled services. Each service focuses on a specific business capability and can be developed, deployed, and scaled independently. Here are the key principles of microservices. Let's delve deeper into the principles of microservices, providing real-time examples for better understanding. Single responsibility principle. Each microservice should focus on a single business capability or function. For example, in an e-commerce application, you might have separate microservices for user management, handling user registration, login and profiles, product catalog, managing product listings and details, and order processing, handling cart, checkout, and payment. Decentralized data management. Each microservice manages its own database, which promotes autonomy and flexibility. For instance, in an e-commerce system, the user management service might use a relational database like PostgreSQL to store user data. Meanwhile, the product catalog service could use a NoSQL database like MongoDB to handle product information. This approach allows each service to optimize its data storage according to its needs. Independently deployable. Microservices can be deployed independently, which allows for faster updates and changes. For example, if a new feature is added to the product catalog service, you can deploy that service without affecting the user management or order processing services. This reduces downtime and enables continuous delivery. Technology agnosticism. Teams can choose different technologies for different services based on their specific requirements. For example, the user management service might be built using Node.js, the order processing service in Java, and the product catalog service in Python. This flexibility allows teams to use the best tools for their specific tasks. Inter-service communication. Microservices communicate with each other through lightweight protocols, often using APIs. For example, the order processing service might call the product catalog service via a REST API to check product availability before finalizing an order. This communication is typically done over HTTP or messaging queues like RabbitMQ. Fault isolation. If one microservice fails, it should not bring down the entire system. For instance, if the payment processing service encounters an error, the order processing service can still function, allowing users to continue browsing and adding items to their cart. The system can implement circuit breakers to manage failures gracefully. Continuous delivery and deployment. Microservices support CI/CD practices, enabling frequent and reliable updates. For example, a team can continuously integrate changes to the product catalog service and deploy it to production multiple times a day, ensuring that users always have access to the latest product information without waiting for a full application release. API. First, designing APIs. First helps establish clear contracts between services. For example, before developing the user management service, the development team might create an API specification that defines how other services can interact with it. This could include endpoints for user registration, login, and retrieval. Monitoring and logging. Each microservice should be monitored and provide logs for better observability. For instance, the e-commerce platform can use tools like Prometheus for monitoring and the ELK stack, Elasticsearch, Logstash, Kibana for logging. This setup allows developers to track the performance of each service and troubleshoot issues in real time. Service-oriented architecture, or SOA. Microservices can be seen as a more granular approach to SOA, focusing on smaller services. To illustrate, in a banking application, you might have services for account management, transaction processing, and fraud detection, each focusing on a distinct aspect of banking operations. Automated testing. Each microservice should be thoroughly tested to ensure reliability. When developing the order processing service, automated unit tests and integration tests can be created to ensure that it correctly interacts with the product catalog and payment services. Scalability. Microservices can be scaled independently based on demand. For example, during a holiday sale, the product catalog service might experience a surge in traffic. You can scale just that service horizontally by adding more instances without having to scale the entire application, optimizing resource usage and costs. By following these principles and examples, organizations can build robust, flexible, and scalable applications that can quickly adapt to changing business needs. The microservices architecture promotes agility, resilience, and efficient resource utilization, making it a popular choice for modern software development. If you enjoy the content and find it helpful, please consider subscribing to the channel. Your support means a lot and will help us create more informative and exciting content for you.